Into biodiesel, and we're just going to go through the steps here of titration for some sesame oil that we got. So first of all, we're going to put 10 milliliters of alcohol into a beaker. Then we're going to put 2 drops of phenolphthalein. We're going to add a few drops of the 1% KOH solution, which is 1% of potassium hydroxide dissolved in 99% of water. And we're just going to do this to get a reaction here. We see it until the color changes, and then we stir it. And then we're going to add 1 milliliter of raw oil. And now we slowly drip the KOH solution till the oil turns to dark purple color. Alright. So when we look at our KOH syringe, and we just use barely, maybe 0.5 of a milliliter. So according to that, we use this chart, which is the biodiesel formula chart, and we add that to our base titration, which is 9. So we have 9.5, and 9.5 gives us exactly how much grams and how much in grams or liters, how much in grams or ounces. How much catalyst to use in our mixture. And then after that, we can perform a pre-batch using those results to see if it actually separates, and it did. So we can go ahead and process the large batch of 35 gallons.
So what you've got is your used veggie oil in a 55-gallon drum. In the top of the drum, we have 3 holes that are lined with a 5-micron filter that's going to help filter out a lot of the food sediment that's stuck in our used vegetable oil. So what we do is we just pour it into the holes, just like this, and it's going to slowly filter through into the bottom of the barrel. And then we have this rotary pump right here that goes all the way down to the bottom of the barrel, and with this hand pump we can crank out the oil to put it into our warming vat. So what we do right now is we just use a 5-gallon bucket and place it under here to pump it out. Ideally we can get a little hose that will actually just hook from here to there and save ourselves a little trouble. And then once you've gotten that part done, you're ready to heat up your oil so that you can mix it with your methanol and catalyst. So what you do is you dump your oil into here and heat it up to 130 degrees. And once you've gotten it to 130 degrees, you're going to transfer it over into here, which will be the mixing station, and you can begin your transesterification.
After the oil has been heated to 130 degrees, it gets transferred into this handy-dandy water heater, where we then add a mixture of potassium hydroxide and methanol, which are mixed together, and then they're added through the pump into the water heater, where a process called transesterification takes place. Now let me tell you what that means. It's a process of exchanging ester compounds by another alcohol. This process can be catalyzed by an acid or a base. An acid catalyzes by donating a proton to the carboxyl group, carbonyl group. And a base catalyzes by removing a proton from the alcohol.
But what does that really mean?
What that really means is, after it gets all hot in here, the molecules get a little excited and want to start exchanging protons. So, after it sits, it's been heating for about 45 minutes, the oil gets circulated and recirculated through over and over again. Then it gets turned off and pretty much it's left to sit for 4 to 6 hours where the glycerin later separates and settles to the bottom. After the glycerin is removed from the oil solution, then the oil can later be pumped into the washing and drying station.
Hello. Now, here is what the oil looks like after it's come out of this and into here from the shower heads, which will be filling in here. This is before the washing and drying stage. As you can see, you can't see straight through it. And at the final product, you should be able to see clearly through it. As you can see, there's a huge difference between the two. Or you may not be able to see. Anywho, so from here, we have the oil sitting in here, and we need to let it off gas because of the catalyst that was added to the mixture. And so so we let it sit for about 4 to 6 hours. And from there, there's going to be a little extra glycerin that has further processed, which will be eliminated by exiting through these valves here. And from there, we end it before any biodiesel escapes. And then we go to the washing process, which is filling water into both tanks to the same level as what the biodiesel is, through these misters, which dances upon the surface and gets all of the surface area of every bit of the biodiesel to get out all of the impurities and catalysts. Anyway, no problem. Okay, so the water is misting out of here, and as it's doing that, it's cleansing all of the biodiesel, capturing water and oil don't mix, so it's capturing anything that is not biodiesel, any impurities or catalyst that's left over. And so water is heavy, so it goes to the bottom gathering all of that, and then that takes an amount of time to do the whole process of washing and filling it up to the same level. And then after that process, when it's fully separated, we're able to open up these valves and allow that water to escape. We close off the valves, and now we just have biodiesel, which is a little more pure than this, but not to that state. Now there's just a little extra water that exists left over. So what we do is we heat up these again, heating up the oil, and then we bring it through these two faucets to allow all the biodiesel to evaporate any remaining water. And then that takes just a little bit of time. And then now it's ready to be filtered for the last time, to be entered into this container, the storage container, which is also hooked up to a pumping station, which is allowing us to service any vehicles which come up close to the building. And this is a nice gauge of gallons and so forth. And that's, in a summation, what takes place.